Today we're taking a look at the indirect calorimetry technique known as the Douglas bag method, which is the gold standard for estimating resting metabolic rate, or RMR. Now there's a lot to learn when it comes to performing the Douglas bag method accurately, so we're going to break things down into 3 parts. Part 1 is preparation. Here we'll go over how to prepare a Douglas bag for collecting an expired air sample, how to assemble a mouthpiece, and what baseline measures and equipment you are going to need. Part 2 is collection. This part delves into how to collect a sample from a participant, key corrections you need to account for, and how to ensure your measurements are as accurate as possible. Finally, part 3 is analysis. This is where we'll show you how to use the Servomex and dry gas meter to analyze your sample, and how to calculate energy expenditure and more from your raw data. As always, I'll put the timestamps down in the description if you want to jump ahead to any particular part, but otherwise, let's get started. In addition to your Douglas bag, you're going to need a Servomex, a dry gas meter, and a gas volume pump. You'll need a mouthpiece, Falcone tubing, and a nose clip to connect to the Douglas bag, some blue roll for your participant once they remove the mouthpiece, gloves for when you're assembling your mouthpiece for your participant, a stopwatch for timing your analysis and collection phases, and a data collection sheet and pen to record your results. Now let's move on to assembling your mouthpiece. To assemble your mouthpiece, you want to start by taking the center part and looking at the arrows which indicate the passage of airflow through the mouthpiece. You then want to rotate the center part so that the side that the air flows in from is on the top. Then take one of your valves and place it into the centerpiece so that you can see that the air will kind of come in from this side. You then take the white end part, screw that on to keep the valve in place, and then rotate the mouthpiece so that this is on the bottom, and now we're working on the side of the mouthpiece that the air will come out. We take our other valve and place this in so that air can come out of this side, and our clear end piece then secures that into place. We then finally want to screw on the bite guard onto the front, and there we have our fully assembled mouthpiece. At this point, you can check whether you have the valves in the correct positions by popping your finger through, and you can press on this side, the white side, to see that it will allow air to pass in through the device this side, but will not let air in from the clear side. Once we have completely assembled our mouthpiece, we then attach the clear side of the mouthpiece to the clear tubing, and the other end of the clear tubing will connect to the right-hand side of the Douglas bag rack. Before we can collect an expired air sample, we first need to evacuate any ambient air from our Douglas bag. Connect the tubing from the dry gas meter to the right-hand side of the main valve and turn the valve to the open position. Switch on the gas volume pump to start evacuating the ambient air from the Douglas bag. Once the numbers on the dry gas meter stop increasing, you can turn the main valve to the closed position, switch off the pump, and disconnect the tubing. Now that our Douglas bag is completely empty, we're ready to collect our expired air sample from our participant. So we're ready now to collect our sample, and we're joined by Lucy, who's going to be our participant today. So the first thing we'll do is we'll get Lucy to pop on the nose clip. And then we'll also get her to insert the mouthpiece, making sure that she grips her teeth onto the little teeth parts, and then pop in this ridge part behind the lips. So what we want to do here is we're going to let Lucy get used to only being able to breathe through her mouth, and we're also going to clear out any of the ambient air that's in the tubing so that when we start our collection, we can be certain that the only air that we're collecting in our bag is the expired air from our participant. We typically want to do this for about 30 seconds, maybe a little bit longer if it's your participant's first time providing an expired air sample. We've completed our familiarization, and it's time to collect our expired air sample. So what we want to do is we want to be turning the main valve on the Douglas bag to the open position and starting our timer at the same time. And today we're going to be collecting an expired air sample for 5 minutes. 3, 2, 1. During a resting expired air sample, it's important that you make sure that your participant is staying as motionless as possible. A general rule of thumb is the more bored they look, the better your results will be. While our participant is providing their expired air sample, we need to check on the atmospheric conditions within the room. There are 4 atmospheric values that we need to check while our participant is providing their expired air sample. The first is the ambient temperature. The second is the barometric pressure, which we also need to convert from hectopascals into millimeters of mercury using the wall chart behind. The next 2 values are for the concentration of oxygen and carbon dioxide that our participant is breathing in while providing their expired air sample. To do this, we just need to take the results from the Servomex while it is running but not connected to any of our ductless bags. This will just be sampling the air in the room and get our fraction of inspired oxygen and fraction of inspired CO2. Now that we have all of our atmospheric values for the room, we can go back to our participant and see how they're getting on. So we're coming to the end of our collection period, and we just want to make sure that we are closing our valve at exactly 5 minutes. After that, we want to give our participant a little bit of blue roll, because once you've had the mouthpiece in your mouth for a period of time, you can often build up a lot of saliva, and we want to always make sure that our participants aren't drooling on themselves. So 3, 2, 1. There you go, Lucy. Stick. And I can take that one off you. Brilliant. And now we've done with our data collection, we need to clean our equipment before we can begin our analysis. So for this, we're going to head over to the sink. The first thing we need to do is put on some gloves, because we are going to be handling somebody else's mouthpiece. Now, first off, we want to take the mouthpiece and we're just going to disassemble it into all the individual component parts back to our starting point. Now, as we're disassembling it, we just want to rinse it off in some running cold water. And we're just going to give each individual piece a thorough rinse off to get any of that excess saliva off, and then pop each piece into the cleaning solution. We want to let the individual pieces sit in the cleaning solution for 10 minutes. The next thing we need to do is we just need to rinse off our nose clip and then swish it around in the cleaning solution for about 10 seconds. Then rinse it off again and then place that onto your drying rack. Next, we'll move on to cleaning our tubing. To do this, we first want to push the tubing into the cleaning solution to get some of the cleaning solution in the tube. We then want to move it back and forth so it runs the full length of the tube. Do this several times. Once you're happy you've thoroughly cleaned the inside of the tube, you then pour the cleaning solution back into the bucket. You then want to get some of your clean water into the tube from the tap. Repeat the same process and then pour that water out down the drain. We then want to hang the tubing up so it can thoroughly dry out. Now that the mouthpiece has been soaking for 10 minutes, it's time to rinse it off, and you want to make sure that you thoroughly rinse it off in the running water to ensure that the next participant who uses the mouthpiece doesn't have one that tastes like cleaning solution. You then want to place each individual piece onto the drying rack, ready for the next participant to use. Now we've finished our cleaning, we can move on to analysing our data. We start our analysis by measuring the concentration of oxygen and carbon dioxide in our expired air sample. First, make sure the Servomex pump is switched off. Next, connect the sample line from the Douglas bag to the sample line of the Servomex. Open the master sample line valve by turning it to face the coloured valves. Simultaneously start the pump, open the coloured valve and start your timer. Note the amount of air removed for analysis. After 1.5 minutes, record the expired air concentrations. After exactly 2 minutes, stop the pump, close the coloured valves and the master valve. Now that we have our concentration values, we can safely evacuate the remaining air in the Douglas bag to calculate our participant's expired air volume. Connect the tubing from the dry gas meter to the right-hand side of the main valve. Reset the digital display on the dry gas meter. Open the main valve on the Douglas bag and turn on the pump. When the bag looks half empty, record the expired air temperature. When the values on the dry gas meter stop increasing, record your expired volume and switch off the gas volume pump. Now that we have all of our results, including all of the values for our atmospheric conditions and all of the measured variables that we got from the Servomex and the dry gas meter, it's time for us to do our calculations. Now we want to start off by just running through and entering in all the values that we've collected for our participant. Once we've done that, we'll get all of the values of interest will be populated in the boxes below. One thing that we can do to check to see whether our collection was a true and accurate resting measurement is to have a look at our RER value. Now, a resting RER value will usually be around 0.7 to 0.8. And as you can see from our value, ours is 0.79, so this is probably a pretty good result. Now, right at the bottom, we can see that our participant will burn 1,106 kilocalories per day while at rest. And bear in mind that this number doesn't account for any energy expenditure or non-exercise activity thermogenesis or the thermic effect of feeding. A bit of a long one, but thanks for sticking with me to the end. And hopefully now you have all of the information that you need to accurately collect an expired air sample from a participant. If you found this video helpful, then please hit the like button. And if you want to be notified of when new videos are coming out, then hit that subscribe button, ring that notifications bell, and you'll be the first to know. Thanks again, and I'll see you in the next one.